Okay, so doesn't matter.
Doesn't matter.
2. Who thinks you should stay? Who thinks you should definitely stay? Stay. Change. Who thinks they should change? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we definitely think you should change. Now, if you change, why should you change? Yeah.
Because each door.
No, I don't want an explanation of why. I said, why do you want to change your guess? Because it will increase your chance of winning. How much will it increase your chance of winning? What do you think?
Double it.
Does it double your chance of winning? Now, I gave you an easy way to actually get a good idea about this, was to actually play the game. It would be nice if more people did that. Can anybody prove it to me? You can't add doors together. Can't do any of that silly stuff.
Like
Yeah.
The way I look at it,
Yeah.
I set it up like door 1, door 2, door 3, and went with the idea that you would always pick door 1 the first time, and so then I wrote out like what your different options would be. So the first one, the like beam would be behind it, and then the door 2 and 3 would be empty, and then for the next like row underneath that, I said that door 1 would be empty, and then door 2 and
I like this a lot.
door 2 would have a bean under it, and door 3
Yeah.
would be empty.
So how many different ways can you play the game?
And so then when you look at it in the end, if you're switching 2 of the times, you're going to win the bean, and the second, and if you switch, but then the other time you're going to get it, but the other way, if you don't switch, you're only going to win the one time.
Yes. This is a really good way to think about it. How many distinct ways can you play the game? How many distinct ways can you play the game? If you have 3 doors, let's call it door A, B, and C. And I'll use a gold star. Another way to say that, and I like the way you did it, it's very clean. Another way to say that is as follows. Initially, when I guess, if I just play this game, what's your initial chance of winning if you just play this game where you pick the door and you get the door? With no help, 1 in 3 chance of winning. Do you agree? 1 in 3 chance of winning. Now, and with no help, what's your chance of losing?
Yeah.
Chance of losing. Do you agree? You have a 2 out of 3 chance of losing. What happens if you initially pick the correct door, but then you change your guess? You will always what? If you choose correct, then switch, always lose. Do you agree?
Yeah.
What happens if you choose incorrectly, then switch?
Always.
You always what? Do you agree with that statement there?
Yeah.
Let's just focus on what is absolutely true. If you choose incorrectly and then you switch, you always win.
Wait, this still with no help?
No. This is with help. You can switch, so therefore there is help.
What is with him? When someone's...
When the guy...
Gives you a chance to choose with no choice. If you just play, if I just gave you 3 doors and said there's a prize behind one and said pick a door, what's your chance of winning? That's what I mean. If you just play a simple game, okay? So if you can switch, but you've initially picked the correct answer, you will always what? If you choose incorrectly and you always switch, if you choose incorrectly and switch, you will always win. So let's go back. Let's go look at this again here. You initially had 1/3 chance of winning. What does that turn into? If you always switch, 1/3 chance of. So this is with switch. 1/3 chance of losing. What does this become? 2/3 chance of. 2/3 chance of winning. So if you always switch, your losing standpoint always turns into a what?
Winning.
It always turns into a win. Do you agree with that, everybody? If you initially pick the wrong one and you always switch, you will always win. What's your initial chance of picking a wrong door? 2/3. Your initial chance of picking a wrong door is 2/3. If you always switch, you will lose on average 1/3 of the time, and you will win how many? 2/3 of the time. If you don't switch, you will win approximately 1/3 of the time, and you will lose 2/3 of the time. So you go from winning 2/3 you go from winning 1/3 of the time to 2/3 of the time. So what do you actually do? Were you correct up here? Okay, I'm speaking English, right?
Yes.
What happens? You were correct. You will double your chances of winning if you switch your guess. You will double your chance of winning. The simplest way I know how to think about it is all of the losing standpoints turn automatically into what? Winning standpoints. Does this make sense to everybody? Yes.
Can you repeat how the chance of winning turns to the chance of losing?
Because look, if you initially pick the wrong door, ready? Ready? Bad, bad, good. What's your chance of picking a bad door? 2/3. So you pick, and you 2/3 chance to pick a bad door, right? When I open a door, which one am I always opening? I'm always opening A. So if you switch, you're always switching to a good door. You're always switching to a good door, right? Right? So if you initially pick a bad door, you are always going to be switching to a... And what's the chance of picking a bad door to begin with?
2/3.
So you're going to win how often? If you always switch. 2/3 of the time.
So if you pick a bad door and
You always
you won't win. And then you switch,
you always win. If you pick a good door and always switch, you will always lose, right? But what's the chance of picking a good door to begin with?
1/3.
1/3. Okay? Does this make sense, everybody? Okay, so you want to talk about the checkerboard problem now?
Yes.
So checkers. What do you think? Can you win?
I don't think.
I tried. Didn't.
What do you think? How many people think yes? No. How many think yes or I have no idea? Yes. How many think yes, you can win this game? You think we have one right there? How many people think no, there's no way to win this game? 1, 2, come on, vote here. This is an American semi-participatory democracy. You have to choose. 1, 2, 3, 4, 5, 6, 7, 9. Yeah. And what about question mark? You have no idea. What?
I vote for yes.
You think 2? You think you can't? You have an infinite amount of space. Anybody not sure? The real question is, can you prove? What happened when you tried to do this?
It just stuck.
It gets stuck. It gets really weird, huh? So, are you ready to understand how this works?
Yeah.
These are challenging problems because I do know of a definitive proof, but it's the kind of thing that you don't really have the math for, but I wanted you to get a feeling for. So you guys are correct. There is no way to do this. Proving that there's no way to do it, that's just challenging in the sense that you will understand this, but just because there's an easy solution doesn't mean it's easy to see. If there's an easy solution, does that mean it's easy to find it? No. Okay, ready? Here's the first piece. Value of that first piece is going to be 1. If I split it, the value of each piece is going to be 1/2. If I split this piece, it's going to be 1/4 and 1/4. The value of the board is always what?
1.
Do you agree with that?
Yeah.
Agree? You totally agree with that? Okay. Okay.
You just assume that
Pieces together, Baldwin.
it means
What's 1 plus nothing? If I split this, what's 1/2 plus 1/2? That's the value of the board. If I split it again, 1/2. It becomes what? 1/4, 1/4, and 1/2, right? What does 1/4 become? 1/8, 1/8, right? What does this become? 1/4 and... So the value, if you add all the pieces, is always going to be what?
1.
Do you agree with that? You're totally good?
Yeah.
Okay, so what was that magical space you wanted? 4 up, right? Yeah, you want that staircase thing, right? See this staircase? Okay, so what was, if I do this out here, I'm going to draw this out here. If I started this with 1, all of these are 1/2, right? All of these are 1/4, and all of these are... Do you agree that they're always going to be the same amount? If there's a piece there. If there's a piece there, that's how much the piece is worth. Do you agree with that? Are you totally cool with that?
Yeah.
Okay, so let's say, for example, I fill up everything on the outside, okay? I'm going to fill up every single space on the outside. What's this piece worth right there? This is 1, that's a half. This is 1/4. What is it? 1/16. So this is 1/16. This is 16th. 1/16 and 1/16, right? And above this is 1/32, 1/32, 1/32, 1/32. Let's just say I was able to figure out how to do this. What's this one going to be worth? Oh, we already know. 130 what? Second, 164, 164. Do you agree?
Yeah.
Okay, so here's the thing. I need to teach you just a little bit about infinite series. It's a little tiny thing you haven't learned yet, but look. If I have 1/2 and I add 1/4 and I add 1/8 and I add 1/16
Never done this before. Yeah.
and I go infinitely if I have an infinite number of those terms, what does it equal? That's not what I am asking you. I'm asking you, what does it equal? If I go on if I keep on going forever, what does it equal? Nope. It does not. What does it go to? If you go on, it doesn't end, everybody. It keeps on going forever. So what does it go to?
Infinity?
No. How do you get a negative number? Those are all positive. What do you think it goes to? You guys, 1. It is equal to 1. I'm not going to prove it to you, but it is equal to 1. 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1/128. If you go on forever, it's still going on right now. What does it equal? 1. We okay with this? I'm not asking you to understand it. I'm not asking you to understand it. I'm not proving it to you. You can learn it later. But it equals 1. What do you think this equals? If I take off the 1/2, what's 1/4 plus 1/8 all the way to going on forever? What's that equal to?
1/2.
I took away half, right? What about 1/8 plus 1/16 going on forever? 1 what? 1/4. And what about 1/16 plus 1/32 plus what's that equal? 1/8. You need limits. We're not doing limits yet, so I'm not going to prove this to you. So, what do all of these, if I add all of these in this column together, what do I get? 1/16 plus 1/32, what do I get? What?
Oh, 1/8.
1/8, that's correct. So all of these add together, what does this add together? What does this one add together to? 1/8, what's this one? 1/8. 1/8, this one is, what's that one? 1/16, and this one is? So what's the next one going to be, do you think? 164. What's the next one going to be? 1/128, right? Are you okay with this so far? So let's just do it some more addition here. What's 1/8 plus 1/8 plus 1/8 plus 1/8 right there? What's that? That's 5/8, correct? Well, what are all these added together? What's 1/16 plus 1/32 plus 1/64? What is that? 1/8. Well, you have 5/8 and what's 5/8 plus 1/8? Which is? So let's see, what did I just do? I just filled up every space. I just filled up every single space. Every single one outside of the little stairwell, right? If I add up the value of all of those pieces, what do they add together to be? 3/4. So the total value outside the stairs is 3/4, which is less than
1.
So what does that mean? No, it would be more specific. So there must be what?
1/4.
There must be 1/4 value always inside the stairs. We filled up the entire rest, and it totally filled up, and it was only what? 3/4. What does that mean? What's the best you could hope to do on this? If you have eternity, right? Let's just go to this for a second here. What was this? This is 1/8, right? This was 1/8. 1/4, 1/4, 1/4. So can you even? You have to? How many of those blocks still have to be full? At least how many? At least one of them, right? At least one of them. At least, yeah. So how does that? What do you think of that problem? What do you think? You don't like it? Do you believe the answer I gave you?
Yeah.
Yeah. Did it match your feeling? You thought you could do it, right? You thought you could. Infinity is an interesting, tricky thing to think about. It's absolutely tricky.
It turns the pattern, it turns the picture to the
Yeah.
mathematics.
Okay, so the walking around question I want to give you, and this is one I have not presented to a class, and it's based on what you just got. It's based on what you just got before we make our transition to Unit 5. So we did this problem. What was this problem called? What am I going to turn it into? So 4 doors here, everybody. If I had door A, B, C, and D. It's the same game, everybody. Shh. I'm going to change the question, though, because you already know the answer to the original one. There's a prize behind one of the doors. There's a prize behind how many of the doors? 1. Same game is played. They only open one empty door. Do you think you should switch your guess? Does it matter? What do you think? Yeah, you definitely should still switch. My question to you is, how much better are your chances of winning if you switch? This is very different, and I want you to think about it. I'm not going to answer any questions. I want you to think about this. I gave you a good framework to think about it in. Now I want you to think about it. Unit 4, test corrections. Other corrections by the end of the week. And the last part of your homework is going to be watch the latest YouTube video pre-lesson. They're back! Oh, there's happy students. Yay.